This is a little video on how to do factoring with the other method when it's hard. Let's look at the trinomial 6x squared plus 23x plus 21. Can I take out something common? No. Is it a difference of squares? No. Is it a perfect square trinomial? No. So the first thing I'm going to do is factor the first term. Well, I can make 6 by 1 times 6, or 2 times 3. How can I make it the last term, 21, 1 times 21, and 3 times 7? Now, either on paper or in my head, I need to go through the different sets of factors to find a way to make 23. 1 times 1 is 1. 6 times 21 is 126. You add those together, you get 127. Go diagonally. 1 times 21 is 21. 6 times 1 is 6. Add those together, you get 27. That didn't work. Move down the list. 1 times 3 is 3. 6 times 7 is 42. Add those together, you get 45. 1 times 7 is 7. 6 times 3 is 18. Add those together, you get 25. That's close. But no, I want 23. It has to be 23. 2 times 1 is 2. 3 times 21 is 63. Add those together, you get 65. 2 times 21 is 42. 3 times 1 is 3. Add those together, you get 45. 2 times 3 is 6. 3 times 7 is 21. Add those together, you get 27. 2 times 7 is 14. 3 times 3 is 9. Add those together. Hey! Those add together to make 23. So apparently 14 and 9 are my two special numbers. I'm going to use the 14 and the 9 to replace that 23 in the middle so that I can factor by grouping. Well, that means I rewrite the problem now as 6x squared plus 14x plus 9x plus 21. Then remember, we split the problem down the middle, and we ask ourselves, what can we factor out of a 6x squared plus 14x? Well, we can factor out a common 2x, which leaves the quantity 3x plus 7. Remember that the 3x plus 7 has to be shared from both sides. So I just pick it up and move it to the other side of the problem. Now the question is, on the right-hand side, what would I distribute through 3x plus 7 to get the original binomial up above, 9x plus 21? What times 3x is 9x? Oh, a positive 3. And is 7 times positive 3 positive 21? Yes, it is. So we put the 3 in front of the 3x plus 7 on that side. So our final answer is we have a shared binomial of 3x plus 7, and we use those two monomials that are outside, the 2x and the 3, to make the second binomial. So our final answer is 3x plus 7 times the quantity 2x plus 3. Here's another example of factoring in the other form, the hard way. So we have the trinomial 8x squared plus 32x plus 30. The first type of factoring I always try to do is take out something common. Oh, this time they're all even. They all divide by 2. So begin by pulling out the common 2, which leaves the trinomial 4x squared plus 16x plus 15. Now we're going to do that weird thing where we look at the 4 and the 15 and its factors. 4 factors into 1 and 4, or 2 and 2. 15 factors into 1 and 15, 3 and 5. Now we play with the numbers to find 2 that will make 16. 1 times 1 is 1, 4 times 15 is 60, 1 times 15 is 15, 4 times 1 is 4, 2 times 3 is 6, 2 times 5 is 10. Aha! 6 and 10 make 16. So I can replace the 16x with a 6x and a 10x, like this. Well, now we're still going to do the factoring by grouping with the stuff inside the trinomial. We just have to remember to bring down the common monomial of the 2. So here's the 2 on the outside of my brackets. I split the problem in half, and what's common to a 4x squared plus 6x is the 2x, leaving inside 2x plus 3, because 2x multiplied by 2x is 4x squared, and 2x multiplied by positive 3 is positive 6x. Remember that the binomial has to be shared, so you just automatically pick it up and put it on the other side, and then you ask yourself, what would I multiply 2x plus 3 by to get the original binomial of 10x plus 15. How do I get that? That's where this 5 comes from. 5 multiplied by 2x is 10x. 5 multiplied by 3 is 15. So my final answer has 3 pieces this time. The common monomial of 2, the shared binomial of 2x plus 3, and the other binomial which we create out of the 2 monomials we factored out, the 2x and the 5. We're done.